So let's go way back in time. 13.8 billion years ago was the Big Bang. From that spark, the matter was jettisoned throughout the cosmos, and 4.5 billion years ago, the Earth coalesced. Most people don't realize, and scientists did not know until just recently, the first organisms on land were fungi. 1.3 billion years ago, 600 million years later, plants arrived. 250 million years ago, at the border of the Permian and the Triassic period, there was a great cataclysmic event. Most scientists think it was an asteroid. Eruptions of volcanoes also occurred. And when this asteroid impact happened, the Earth became shrouded in dust. Sunlight was choked away from the ground. And because there was no sunlight, huge numbers of species disappeared and became extinct. With all that debris that was created, fungi inherited the Earth. The organisms that paired with fungi survived. We march forward again to 65 million years ago. Bam! Another asteroid impact. And fungi re-inherited the Earth. From these two asteroid collisions has steered the evolution of life on this planet. And we are in constant symbiosis with fungi. We now are experiencing 6X, the sixth greatest extinction on this planet that we have thus far have been able to be determined. And with over 50% of the species now estimated to become extinct in the next 100 years, we face a real problem, not only for the survival of the human species, but many other species that we carry with it. There are approximately 1 to 2 million species of fungi in the kingdom. About 150,000 of those are mushroom-forming fungi. About 10% we have thus far identified, 14,000 species. So more than 90% of the species out there we have not even identified. And yet we're losing species, like rivets out of an airplane. How many rivets will you lose before we approach a point of catastrophic failure? And I often wondered if there's a united organization of organisms, otherwise known as uh-oh, and if every organism on the planet had a vote, will we be voted on the planet or off the planet? I think that vote is occurring right now. And we need to look downstream into future generations to see what the implications are of our current activities. So, amazing fossil. This is 420 million years old. It's Prototaxites. It was published just 2 weeks ago in the Journal of Geology by a mycologist by the name of Boyce, a big mystery for many years. It's a large fungus. 420 million years ago, the continents were all together in what's called Pangaea. And they separated. They found these in Quebec and now in Saudi Arabia and throughout the entire world. It was the tallest organism on land 420 million years ago. This is what the land was thought to look at. These were the tallest plants. And these fungi were up to 30 feet tall. Think of that. Fungi had evolved way before humans had evolved. The oldest fungus found so far has been a piece of amber, not this one. This one's 15 to 20 million years old, but it's a cordyceps mushroom that's found in a piece of amber 100 million years old. 100 million years ago, if you were on this planet and you walked around, you'd see a mushroom, you identify it. But if you saw a little vole-like creature, would you say, that's going to be humans? Hardly so. These are ancestral organisms. They've been around a long time. And because they have developed exquisite strategies, they're extremely clever at adapting to catastrophia. This is the largest organism in the world, is right here, and Dusty and I live right there. This is the Columbia River, we're down here. And I hired an airplane twice, and the pilot and I became friends, so he didn't charge me. I really like that. But, but this is the largest organism in the world. It's a mycelial mat in eastern Oregon, 2,200 acres in size. Over 2,000 years old, and it's a single cell wall thick. Think of that. How can the greatest organism on Earth be a single cell wall thick and yet achieve that mass? Because it's in constant communication with this ecosystem, developing exquisite strategies for survival. And I think we can harness upon those strategies. Mycelium munches rocks. It produces calcium oxalate and oxalic acids. And the oxalic acids are joined by 2 carbon dioxide molecules. So it's counterintuitive. We respire carbon dioxide, so does mycelium. But the mycelium it creates carbohydrates, but at the same time, it takes calcium out of rocks. And in doing so, pockmarks the rocks, and this is why the fungi came onto land first. It was able to dismantle the rocks and crumble them. But this is the way of sequestering carbon dioxide out of the atmosphere, and my solution to global warming is to invest in humus, using mycelial allies as a way of being able to bring carbon dioxide out of the atmosphere. We live on a thin skin of soil that has given us life, and it's time that we reinvest in the carbon bank of that humus layer. The mycelium then will start producing a mushroom. Mushrooms are so powerful, like Larry mentioned. This is a shaggy mane. They break through asphalt. There's a helical spiral matrix of cells that goes through what's called a dolipror septum, and this spiral forms, and water's pulsing through a one-way gate valve, and it can break concrete as well as asphalt. These are miniature microscopic explosions that have Herculean forces behind them. We did a number of experiments. I'm going to try to get through 5 inventions in 11 minutes here. This is one that we did in Bellingham, Washington, at the Department of Transportation. There was a diesel spill there for 40 years, and the Department of Ecology was fining the Department of Transportation. They invited scientists to try remediation trials. We went up there. There's 4 piles, 1 test pile, 1 pile was treated with bacteria, 1 with chemical enzymes, and 1 we inoculated with our oyster mushroom mycelium. This is over 200,000 parts per million of PAHs, polycyclic aromatic hydrocarbons, basically diesel, bunker C. The mycelium absorbs the oil. It produces lignin peroxidases and cellulases that break carbon-hydrogen bonds, the same bonds that hold hydrocarbons together. And this mycelium sweats antivirals, antibiotics, enzymes, and these sweat droplets are customized to the habitat to which they are encountering. 4 weeks later, we went back, and our pile was covered with thousands of mushrooms. None of the other piles had any sign of life, and our pile reduced the PAHs from 20,000 parts per million to less than 200 in 8 weeks. The mushrooms sporulated, they start to rot. Then something else happened. The mushrooms became up to 16 inches in diameter. These are what we call happy mushrooms. These are really big mushrooms. Any of you collected oyster mushrooms, they don't normally get this large because they have lots of nutrients to be able to eat the oil. And so then after sporulation, the mushrooms rotted, and they invited bacteria started to grow. But then something else happened. Plant communities came in. Birds came after the larvae because as the insects laid eggs in the mushrooms, larvae grew. Birds came in, brought in plant seeds. Our pile became an oasis of life. And this was an epiphany for me and a pivotal moment in my understanding that these are gateway species. These are primary saprophytes that open up the door leading to habitat restoration. So 2 of my fungi actually were used by the Department of Defense to break down VX, which Saddam Hussein did use against the Kurds and did kill over 20,000 people. One of my mushroom strains, after a series of experiments, the sole nutrient source was VX, a potent neurotoxin. We were able to train the strains so the only thing that they needed to consume was the potent neurotoxin. This became quickly black boxed by the Department of Defense.